Hello sir, I am Janel Bibilolo and I'm gonna be discussing about the antennas that are present in the smartphones. So for my introduction, I'm going to be tackling about the development of mobile phone antennas. So in the first generation of mobile system, the system was operating at 800 MHz and is known to be analog. The first antenna handset for 1/4 of wavelength has length about 9.4 cm and it was one antenna only. The first mobile phone was Motorola Dyna TAZ8000X with Type 3 antenna which is not used anymore in modern design of mobile phone antennas. However, it is still used in different wireless LAN access points. So in the 1990s, the second generation launched which offered new services such as text messages and it is operated at global system for mobile communication at 900 MHz, or later on at 1800 MHz, unlikely in the first generation. So the second generation handset antenna has two antennas, monopole and helix, with only single band supporting. So in the 1997, Motorola produced a mobile phone device called Motorola MR601, which was the first dual band GSM phone. It supported GSM 900 and GSM 1800 dual band, and its antenna consists of two antennas helix which was traveling wave in the shape of a corkscrew with circularly polarized and whip antenna which can be considered as dipole antenna, and it is omnidirectional radiation pattern. That model phone offered the ability to access network in over 70 countries by the end of 1997. And the first dual-band PIFA operating at GSM 900 and GSM 1800 invented by Prof. Peter Hall in 1996. The first dual-band PIFA a slot with a certain geometric dimensions lead to support two different bands. The development timeline of mobile phone has several significant steps. One of them was in 1999 when Nokia launched Nokia 3210, the first mobile with fully internal antenna, which support both GSM 900 and GSM 1800 dual band, and was one of the most popular handset with over 160 million being sold. So in the 1999, Professor Peter Hall comes back with the first triple band PIFA which operates at GSM 800 to 1800 and 1900. He designed triple band PIFA with two slots in the ground plane of the PIFA antenna. So prior to my pre-test, the questions that I have gathered comes from my introduction that I have discussed a while ago. So now I'm gonna be proceeding to my discussion, the smartphone antenna. So I'm gonna define first what is the meaning of a smartphone and an antenna. So a smartphone is a mobile device that combines cellular and mobile computing functions into one unit. In radio engineering, an antenna or aerial is the interface between radio waves propagating through space and electric currents moving in metal conductors induced with a transmitter or a receiver. So first, I'm going to differentiate a mobile phone and a smartphone. A mobile phone and a smartphone are both mobile devices that can be used to call and send text, but the difference is that mobile phones often have a physical keyboard, while smartphone keyboards are usually virtual or it has a touchscreen interface. So moving on, smartphone antenna. The antenna of a mobile phone, which is terminal equipment for transmitting and receiving electromagnetic waves, plays a vital role in mobile communication. A dramatic growth has been seen in the mobile industry. it has evolved from analog to digital second generation communication, then to a high data rate third generation wideband code division multiple access. So further to packet optimized 3.5G high-speed packet access and fourth generation long-term evolution and LTE advanced system, and now moving towards the fifth generation wireless communication system. So a smartphone antenna design is reasonably complicated because of different communication standards and regulatory systems. In addition, there are multiple antennas on a smartphone, and most of these antennas are PFAS or a custom printed antenna. The main challenges for the mobile device antenna are small size, built-in, multi-band, and coexistence of multi-radio system in the multiple input, multiple output system. So LTE provides the essential and far-reaching vital solutions for wireless communication system. So now I'm gonna be discussing the antennas that are present in the smartphone in the smartphone. So the first is the PIFA, or the planar inverted F antenna. This is widely used in mobile phone antennas and designed due to its advantage such as the specific absorption rate and the less interaction with handheld environment. But one of the significant problems of PIFA antennas is that PIFA antennas have a narrow bandwidth. Wideband and multiband PIFA antenna can be a solution of that problem. So the other motivation is to investigate and design a wideband PIFA antenna. So in general, PIFA antennas have a disadvantage that PIFA's antennas have a narrow bandwidth, but on the other hand, PIFA antennas have many advantages, such as the best SAR rate, or the specific absorption rate, low profile, and easy to be integrated inside a mobile phones, which make PIFA antennas the best candidate for mobile phones antennas. So here are some of the antenna present in a smartphone. The first is primarily serial antenna, which can transmit and receive. Diversity cellular antenna, which can receive only. GPS antenna, which can receive only. And Wi-Fi antenna, which can transmit and receive. And the next is the near field communication antenna. So the first is the primary cellular antenna. So the primary cellular antenna is the primary communication antenna on a smartphone, and hence is extremely important. This antenna typically is the only cellular antenna that transmits, so it has many specifications and requirements to meet. The requirements for the transmitting portion of the primary cell are first is the SAR, or the specific absorption rate, which measures the amount of energy absorbed by the human body when the phone is transmitting in maximum power. The peak absorption must be less than 1.6 microwatts per gram in the US, or over 1 gram of tissue, and less than 2 microwatts per gram in the Europe, or over 10 grams of tissue. The location and type of antenna significantly affect the SAR value, and if the SAR is too high, you can sell your phone. This mandated by the FCC in the US, or various government regulatory agencies worldwide. So the next is TRP, or the total radiated power. So cell carriers, AT&T, Verizon, China Mobile, or etc. set the minimum specifications for the amount of total radiated power, or TRP, for every frequency band that the phone will support. So in addition, there are specs for the TRP when the phone is mounted on a mannequin head. TRP is a function of the radius transmits power and the antenna efficiency. So next is the TIS, or the total isotropic sensitivity. So in addition to TRP, the cellular carriers set minimum specification for the amount of total isotropic sensitivity for every frequency band. The phone will operate the phone will operate in. And similar to TRP, there are specs for the TIS when the phone is mounted on a mannequin head, but the TIS is a function of the radio's conductance sensitivity, the antenna efficiency, and the distance. So the next is the type of antenna that are present in the smartphone is the antenna diversity, or also known as space diversity or spatial diversity. It is one of several wireless diversity schemes that uses two or more antennas to improve the quality and reliability of a wireless link. Antenna diversity is especially effective at mitigating this multifaceted situation. This is because multiple antennas offer a receiver several observations of the same signal. Each antenna will experience a different interference environment, and thus, if one antenna is experiencing a deep fade, it is likely that another has a sufficient signal. Collectively, such a system can provide a robust link. While this is primarily seen in receiving systems, the analog has also proven valuable for transmitting systems as well. So the next is the GPS antenna. The GPS antenna is becoming a must-have feature in mobile phones, with major manufacturers launching new designs regularly, and second-tier manufacturers rapidly catching up. So in a quick test of an early GPS-equipped phone shows that although the inconvenient GPS chip or the chipset has high sensitivity, the integrated and end result cannot perform in low signal conditions. Several challenges facing the phone designer are responsible for this. So with the main two being the antenna performance and interface in the GPS band generated within the phone platform itself. The GPS satellite signals are notoriously weak compared to the familiar terrestrial signals with a broken station or mobile phone towers. But however, if an appropriate antenna has a clear line of sight to the satellite, excellent receiver performance is in the norm. So the next is the Wi-Fi antenna or the Bluetooth antenna. Wi-Fi and Bluetooth antennas work by transmitting and receiving the electromagnetic waves from the antenna to the receiver. They are one of the most useful services in the new smartphones. Wi-Fi antenna is the smallest antenna and works with the highest frequencies. The most useful Wi-Fi antenna in mobile phone that is connected to a small chip which work for the Wi-Fi and Bluetooth antennas at the same time. Also, we can have two antennas which cover 2.4 gigahertz. The Wi-Fi frequencies are the highest of all frequencies on the device. The Wi-Fi frequency is divided into two bands, the 2400 and the 2484 megahertz, which also includes Bluetooth, and a 5850 megahertz. All Wi-Fi antennas support this band, and typically the Wi-Fi antenna is connected to a chip that does both Wi-Fi and Bluetooth. This designing antennas for Wi-Fi and Bluetooth is basically the same thing. So phones are now shipping with the 5150 to 5850 megahertz band included in Wi-Fi, so that the Wi-Fi antennas is often dual band. It is also possible to have two Wi-Fi antennas, one for 2.4 gigahertz and one for the 5 gigahertz band. Because Wi-Fi is the highest frequency on the mobile device, the antenna will be the smallest antenna. Hence, using quarter wavelength antennas leveraging the device ground plane can make for a very, very small Wi-Fi antennas. So the Wi-Fi antenna is typically located on the top of the device near the GPS antenna and the Cellular antenna. And note that there are no TRP specs, so in general you don't want the Wi-Fi antenna to have too high of an efficiency, or the specific absorption rate and peak gain values will require a large conductive power backup. So the last is the NFC antenna or the near field communication antenna. NFC-enabled smartphone uses an NFC controller chip which connected to an NFC antenna. The NFC technology was first introduced into smartphones in September 2011 and is now widely integrated into most phones, whether they are iOS or Android based. The controller chip can be defined as a specialized central processor unit which can accept instructions provided by the application processor and the processes those instructions to complete the NFC tag detection and or reading tag content. The NFC smartphone antenna can be positioned either on the top, middle, or bottom of the back side of the phone and is rarely indicated on the phone case. During an interaction, the tag's antenna picks up both the necessary energy to operate and an external signal provided by the smartphone and activates the tag by means of electromagnetic induction between the two antennas. So here is my post test, or these questions came from my discussion about the what present in this smartphone. So I'm going to proceed now to the conclusion. So for the conclusion of this topic, mobile phone antennas have several critical parameters such as the geometric dimensions, dielectrical materials which are used in designs, and the ground plane of the antenna. All of that should be taken into consideration for optimization processes. So the fast development of mobile phone devices add more demand on optimization of the antennas. For the modern smartphones, especially the high-end models, have shown a clear trend toward the thinner designs and higher integration. Yun lang po. Thank you po and God bless.